Welcome back to Maths with Mrs. J. In our first unit circle video, we covered quite a bit of ground. I just wanted to go through the main points of that again before we continue, because there was a lot to process there. The first thing we talked about was the fact that up until now, you would have only considered sine, cos and tan ratios for angles that are less than 90 degrees. So you've only worked with right-angled triangles. It hasn't been relevant to think about angles that might be bigger than 90 degrees. Now that we've introduced this concept of the unit circle, we can in fact think about and define sine, cos and tan for any place along this unit circle. Now, why is it a unit circle? Well, because it's got a radius of 1 and its origin is the centre of the circle. And what we're doing here is we are moving around the outside of this circle, or describing our position depending on how far we've moved around the outside of that circle, if we're talking about our new thing, which is radians. So with our radians, this is the thing that we really need to think about because it's new. Because we have a circle of radius 1, all the way around your circle, so all the way around is going to be 2 pi, because 2 pi r is circumference of a circle. So it's 0 radians here. By the time you've gone halfway around, you've gone pi. All the way around, you've gone 2 pi. So halfway between pi and 0 is, of course, your pi on 2. And halfway between your pi and your 2 pi is 3 pi on 2. Your degrees is as normal. It's just like we're rotating our radius anti-clockwise from the positive direction of the x-axis. So here's your angle in here. And we're going this way, anti-clockwise. So obviously you've gone 90 degrees if you're up here, you've gone 180 degrees if you're here, you've gone 270 degrees down here, and 360 degrees if you're here. You can describe any point on the outside of this circle, wherever you want to put it. You can describe it either in radians, which is going to tell you how far around the outside of that circle you've moved, how far around the circumference, or you could talk about it in terms of degrees, meaning what's the angle that you've moved around. But of course, we can also talk about our x and y values. It's a Cartesian plane. Now, the vital bit of information that we are going to have to think about a lot over our unit circle work is this new bit of information here, a new way of thinking about our trig ratios. Sine, in future, we're going to think of as the y value, most of the time, unless we happen to have a right-angled triangle. Cosine is the x value, and tan is your y value divided by your x value. Now, before we move on in this topic, we need to do a little bit of work on converting between degrees and radians. Now, the good thing is that we have this very reliable source of information, and that's basically what we use. We know that pi radians is the same as 180 degrees. So let's move on to our next slide. And we'll have a look at that. Alrighty, so we've got that pi radians is 180 degrees, or similarly, 180 degrees is pi radians. Let's work with this one first, going from radians to degrees. If pi radians is 180 degrees, then 1 radian is going to be 180 divided by pi degrees, isn't it? We've divided both sides by pi. So theta radians will be 180 on pi times theta degrees. That was meant to be a radian, sorry about that. So to go from radians to degrees, you're going to multiply by 180 on pi. Let's put that down in our little rule here. You're going to multiply by 180 over pi. All right, let's do the other one. Same thing, we're going to sort of the unitary method here. We're saying, well, if 180 degrees is pi radians, then 1 degree is pi on 180 radians. So theta degrees is our pi on 180 times theta radians. So to go from our degrees to radians, back the other way, makes sense that you either divide by 180 on pi, or the same thing is multiplying by pi on 180. All right, so let's fix this up here. Okay, we're going to do some examples of this now. So bear with me. Just get to the next slide. All right, and we've got some examples. So again, let's just remind ourselves of the rules. We know that to go from radians to degrees, you're going to multiply by 180 on pi. And to go from degrees to radians, you're going to multiply by pi on 180. I'll tell you how I remember this. Well, it's easy to remember if you just always go back to the start and know that pi is the same as 180. But going from degrees to radians, you're wanting to add in some pi's. This is very unmathematical, but you're wanting to have a pi in your radians speak, usually, if you can. And going from radians to degrees, you're wanting to sort of get rid of the fact that there's a pi there. So that's why you're dividing by pi that way. Not highly mathematical, that way of thinking, but it might help you remember. Generally speaking, the only way we can give an exact position in radians is if it is some multiple of pi, which is why we normally work like this. All right, let's do some examples just quickly. Converting to radians. So we've got 45 degrees. So what do? Degrees to radians, we're going to multiply by pi on 180. Now, we're going to often be able to cancel here. 45 goes into 45 once, 45 goes into 184 times, so we get pi on 4. I'm not going to write the C from now on. If there's a pi there, you can assume it's radians. All right, 60 degrees, same thing. 60 times pi on 180. Again, we can cancel and we get pi on 3. You will start to get to know the common ones once you've done a few. This one here, again, multiply by pi on 180. Now, 90 will go into 180 twice. 90 will go into 273 times, so we get 3 pi on 2. And last one, going from degrees to radians, again, we multiply by pi on 180. Well, we can divide them both by 10, and then we can divide them both by 3, and we get 5 pi on 6. All right, going back the other way, what we're going to do is we are going to multiply by 180 on pi. Now, the pi's will cancel. What else can we cancel? Well, 4 goes into 4 once, 4 goes into 180, 45 times. So we end up with 3 times 45, which is 135 degrees. You're allowed to use your calculator to help you here, but hopefully you don't really need to. Pi on 6 times 180 on pi. The pi's will cancel. 180 divided by 6, when you cancel or divide, doesn't matter which way you think about it, you get 30 degrees. 5 pi on 3, we're going to multiply by 180 on pi. Cancel the pi's, cancel, and we're left with 300 degrees. Last one for now, we're going to multiply by 180 on pi, cancel your pi's. All right, and you're going to get 7 times 45, which is, 8 times 45 is the same as 4 times 90, which is 360. So this will be 360 minus 45, which is 315 degrees. That's sort of like 1 3/4 lots of pi. All right, that should do for this video. In our next video, we're going to start talking about the other quadrants of our unit circle.